Okay, you guys, so I'm back with another t-test, but this time we're going to do an independent samples t-test. I'm not going to do the whole thing from start to finish with the x minus m squared thing, because I really do feel like you guys should understand how to calculate variance at this point. So what I'm going to do is I'm going to sort of show you, hey, imagine you're given this information, and then solve for the t-test with this information. So let's just sort of orient ourselves to the problem here. We have two groups. There's two different sample means. That right there tells you that we are doing an independent samples t-test, okay? We have two groups in our study. We have one group that's going to take an exam in person, and we're going to have another group that's going to take an exam online. And we're interested to see whether or not they perform differently depending on whether or not they're in the in-person group or the online group. I'm going to say that we don't really have a direction in mind here, so we're just going to say that we think that there will be an effect of whether or not it's in person versus online, but we don't know which way. So you might already know that that is going to be a two-tailed test. So if I'm talking about my, let's see how far I can, a research hypothesis, got H1. Oh, I probably do need to say who's mu1 and mu2. So let's just imagine that my in-person people here are going to be my mu1 people, and then my online people will be my mu2. Okay, so we're going to say mu1 is not equal to mu2 because that's my two-tailed hypothesis. Okay, and my null hypothesis here will be mu1 is equal to mu2. Okay, that's step one. We've got our hypotheses done. Yay. Remember, step 2 is all about getting the standard error, okay, which is that S with a lower, like, subscript M1 minus M2 next to it. That's the standard error. If you remember, all these formula sheets for all these t-tests start with variance. That's sort of the beginning point. And that's an important thing for me to note here, especially for an independent samples t-test, because you really do, again, need to know what these symbols mean in terms of what you're given. So, first thing, when we're looking at what we're given means for both of our groups, which is good. We're given the number of people in each group, and notice how they don't match, okay? Obviously, most of the time we, as researchers, we aim for them to match. We're like, okay, I want 20 people in both groups. But things happen, people drop out, they have data that's not good for some reason, so somebody might be lost here. So we'd have 20 versus 19. What is your lowercase s? It is not variance, and it is not sums of squares, and it is not standard error. So the only other option is that it's the standard deviation, okay? So what you have right now is a standard deviation for both of your groups. If you remember with the independent samples t-test, at no point do we actually need the standard deviation for both groups, right? Because we need variances so that we can find our pooled variance. But that's okay, because I can easily turn a standard deviation into a variance, right? So if I wanted to do that, if I wanted to turn a standard deviation into a variance, I'm just going to take my standard deviation and square it. So 2.5 squared will be 6.25. And then over here, I've got 3.6 squared, and that will be 12.96. And good job. All right, so we've got our variances. The next step is to do the pooled variance. So for these, you have to know your degrees of freedom, which I haven't written anywhere. So I'll come up here and just say my degrees of freedom for group 1 is 20 minus 1, which is 19. And my degrees of freedom for group 2 is 19 minus 1, which is 18. And if I were to add those two things together, I could get my DF total, and that would be 37. Okay, so that would be my total. All right, I'll need those to be able to calculate my pooled variance. So I need my degrees of freedom for group 1, which is 19, divided by the total degrees of freedom, which was 37. And I'm going to multiply that by my variance for group 1, which is 6.25. And then I'm going to kind of like, you know, people do this all sorts of different ways, but I'm bracketing this off, and that is just helpful for me because if you try to put all this in your calculator at one time, I cannot guarantee that it's going to come out nice and right. So I'll do this part first probably, and then come back around and do the part for the second group. So degrees of freedom for my second group is 18 divided by the total one, 37. And again, multiplied by the variance of 12.96. Okay, so I've got 19 divided by 37, which is like 0.51, a bunch of stuff, multiplied by 6.25, and I'm going to do that as 3.21, plus, got 18 divided by 37, multiplied by 12.96, and I got 6.30. You could maybe argue with some rounding back here. I'll do 6.31 because the rounding will probably bump it up. Okay, so if I add these two together, I can already tell I'm going to get like 9.52. And it's important for me to make sure that that's somewhere in the middle of the two variances that I have, 6.25 and 12.96. Getting something that's 9-ish is probably going to be right. So we've got 3.21 plus 6.31 equal 9.52. Okay, so that is my pooled variance. After that, you will need your S2Ms, or S squared M's, however you want to think about them. Now, you guys are going to be different for each group here because our n's are not the same. So I need my pooled variance number, which is 9.52, divided by n of my first group. Okay, don't get confused by this. I did use capital N's here. I'm so sorry. It's just a habit. But I am just talking about this group of people. So I would say 9.52 divided by 20 for them. All right, so 9.52 divided by 20 equals 0.48. So 0.48, I'm going to put a little circle around that because it's running together. Okay, and then I need to do the S2M for my second group, which is 9.52 divided by the N for my second group, which is 19. So 9.52 divided by 19 equals 0.50. Okay, at this point, I'm going to erase some stuff so that we have some space here. Yeah, I'll leave the means because we're going to need those. I think I can erase everything else except for the S2Ms because I've got 0.48 and 0.50 as my S2Ms. We're still not done with step 2 because we have to get the standard error. Okay, so that's sort of this goal we're still working towards. All right, we'll have to remember that it's two-tailed. Okay, so, okay, SM1 minus M2, that's a symbol for standard error here. We're going to take the square root of our two S squared M's added together. So I've got 0.48 plus 0.50. All right, so 0.48 plus 0.50, and that's 0.98. Then we're going to take the square root of 0.98, and we'll get 0.99. That's fun. Okay. Once we have that, we can move on because that was the whole goal of step 2. So I'm going to move on to step 3. Let's just say our p-value here is 0.05. It is two-tailed. And I erased all our degrees of freedom stuff. Oh, I left that one. So I'll go ahead and take that one away too. But we just want our DF total one here. That's the only one that matters for finding our cutoff score. And that was 37. So if you have your chart in front of you, we're in the two-tailed section. 0.05. Our degrees of freedom is 37. We do not have a 37 on here, so what I tend to do is just go with whatever's closest. So 35 is actually closest, so I'm going to use that one. 35.05, two-tailed, so it should be 2.03 on both sides. So 2.03 here, and negative 2.03 here. Okay. So then for step 4, we just need to calculate our t. Remember I made this group 1 and this one's group 2, so I'm going to have 85 minus 75 because those are my means, divided by the standard error, which was 0.99. It's going to be quite massive. So 10 divided by 0.99. So this 10.10 is our t. Does that pass our cutoff? Absolutely. It definitely does. So for step 5, we would say reject the null. Okay. So this would mean that taking the exam in person does have a different effect than taking it online. You could obviously, even though your test was two-tailed, you could look at those means and know that people did better when it was in person than when it was online. The only thing we don't have right now is our effect size. So remember that lowercase d is Cohen's d, and that's our effect size. So if the problem asks you for that, you could easily calculate that. The only thing you don't have right now for that equation is your pooled standard deviation. So in order to get that, let's see here. We need our pooled standard deviation. We just need to be able to take the square root of our pooled variance. Okay, so our pooled variance, if you remember from a little bit ago, was this 9.52. Okay, so I'm going to do square root of 9.52, and I get 3.09. All right, but that's not our answer here. We still need the effect size. So for Cohen's d, you see that? That's a d. We're going to do 85 minus 75, same numerator as our t-test, divided by our pooled standard deviation of 3.09, and it's still going to be crazy big. So 10 divided by 3.09, and you get 3.24. So that is a very, 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 very large effect size. Okay. Okay, hopefully that was helpful. Again, if you have any questions, you can come see me. But that was an independent samples t-test.